Okay, so in this example here, we're actually finding the domain of the function f of x equal to the square root of x to the fourth minus 6x squared plus 5. And so this is kind of like a compositional function. However, we know that we have a square root, and we're not allowed to take the square root of a negative number because that puts us in complex number territory or imaginary number territory. And so what we need to do is to find the domain, which means that we got to make sure that the radicand is greater than or equal to 0. Okay, and so what is the radicand? Well, the radicand is just that polynomial x to the fourth minus 6x squared plus 5. And so we need that polynomial to be greater than or equal to 0. All right, and so of course that polynomial is x to the fourth minus 6x squared plus 5 greater than or equal to 0. All right, well, step one, this is a polynomial equation, and we have to make sure that we have an inequality where 0 is on the left or right, and the polynomial is on the left or right. Okay, so that's done already. Step two is find the zeros of the polynomial, the real zeros of the polynomial. Okay, so we need to solve that equation. All right, so we have x to the fourth minus 6x squared plus 5 equal to 0. Okay, and so this here we could solve by factoring. It factors as x squared minus 1 times x squared minus 5. All right, the first one's a difference of squares. I think that factors as x minus 1 times x plus 1. Of course, x squared is minus 5 is a difference of squares as well, but I'm going to leave it as an irreducible quadratic function over the integers and solve each one of these. So we could see x equal to 1, 0, and x equal to negative 1, 0, but then x squared minus 5 is 0. You could use quadratic formula, but we could just solve or isolate the x squared term to get x squared equals 5, and then take the square root on both sides to get plus or minus the square root of 5. Okay, so we have our zeros. And then next step 3, is create a number line or a table or something, and where we have our our values. So square root of 5, this might be helpful to get an approximation of that. So the square root of 5 is about 2.23, actually about closer to 2.24 if I round to the hundredths place, so plus or minus 2.24. All right, so there we go. Let's go ahead and create our number line here. So we got a negative root 5, and then a negative 1, and then a positive 1, and then positive root 5. Okay, so we know the function is going to be 0 at those values there. And we need to take some test values. So I'm going to choose something like negative 4, negative 2, 0, and say positive 2, and then positive 4. So those are our test values. Negative 4, negative 2, 0, and 2 and 4. Okay, and we need to figure out what the sign values of those are. All right, so we plug them into our polynomial. So negative 4, we're going to get negative 4 to the fourth power minus 6 times negative 4 to the second power plus 5. And so doing the arithmetic there, we get 165. Then we plug in negative 2. Negative 2 to the fourth power minus 6 times negative 2 squared plus 5. Doing the arithmetic gives us negative 3. And then we have the polynomial evaluated at 0. And so that would give us a 0 to the fourth minus 6 times 0 squared plus 5, which spits out 5. All right. Then the polynomial evaluate the next x value, of 2, so we get 2 to the 4th minus 6 to the 4th squared plus 5. Doing that computation gives us a -3. And then the polynomial evaluated at the next test point of 4, we have 4 to the 4th power minus 6 times 4 to the 2nd power plus 5, which gives us 165. All right, so we could see that our test value of -4 was a positive value, so we know on the interval from -infinity to -√5, the polynomial would be positive there on that interval. And the interval from -√5 to -1, we see that it's a negative. And so our polynomial will be below the x-axis there, spitting out outputs that are negative. In between -1 and 1, we see that our test value of 0 gives a positive 5, so it's positive in between -1 and 1. Between 1 and square root of 5, we took a test value of 2, we got a negative out, so the polynomial will be negative in that interval. And then root 5 all the way to positive infinity, we took a test value of 4, we got a positive out, so we get a positive sign value there. All right, so we could see then, or interpret this now, the solution of p of x greater than or equal to 0 is the interval from -infinity to -√5, -1 to 1, and then √5 to positive infinity. And to get that there, it's the union of those three intervals. Now, keep in mind that implies that that interval there, or that inequality, implies that our domain of the function f of x equal to the square root of x to the 4th minus 6x squared plus 5 is the interval -infinity to -4, closing bracket, union, bracket, -1 to 1, bracket, union, open bracket to square root of 5 to positive infinity. Now notice we're including the endpoints because the radicand, the square root of 0 is okay, and the radicand can be 0. And so that's our domain.